Next on the agenda, let's talk a little bit about rounding. We kind of hinted at it a little bit in theory, right, through year-long division or just being out in the world. Who knows where you find these numbers. You could end up with like a pretty long decimal number. And you might need to round it off, that is, sort of make a shorter version of it, where you're kind of chopping off some number of digits just to sort of make a more manageable number. It could be for, in a physics class, a significant digits kind of reason where you can only be so accurate. It could just be for sort of practicality's sake. Like I said before, calculators kind of do this automatically sometimes. And so we just need to be able to make sure that we sort of understand the process and sort of we can do it on our own. Let's sort of put an example number down, and we'll talk through the process of rounding it to a certain number of places. So, I don't know, 536.475.28 or something, let's say. And so, this is kind of 5 digits deep in the decimal point. Maybe we would like to sort of round this off. Let's maybe kind of round it from we'll sort of work our way maybe from right to left. So this is 5 digits. Let's round to 4 decimal places. The 4th decimal place, of course, right? Tenths, hundredths, thousandths. That's going to be 10 thousandths. So, how do we round? How do we do this? Let me rewrite our number. Most of these digits are going to just stay exactly as they are. They're not going to change at all. The idea here is that we would like to sort of end our number after the 4th decimal place, right? So we're trying to kind of erase this 8. But the idea is you need to make sure that when you do this, you don't necessarily just erase the 8. You want to make sure that you sort of give credit where credit is due for any kind of value that's already there. In particular, what you're doing is you want to look and see. So we're going to round this to 4 decimal places, so you need to look 1 digit back to the 5th digit, and you're looking for a 5 or higher. You're looking to see if that digit is 5 or higher. If it is, then what you're going to do is you're going to round up. And what that means is you're going to take your actual last digit, which in this case was a 2. It would round up to a 3. The idea here is that in some sense, right, if you've hit a 5 or higher in the digit sort of one past where you are, you're more than halfway to the next digit. If you think of this in terms of like, something like rounding a score on a quiz, or rounding a final grade in class, right? If a 90% is an A- and an 89% is a B+, which it is in our class, what do you do with somebody who gets an 89.5 or an 89.6 or an 89.7? Technically, sure, the first couple digits, they're an 89, but in theory, right, you've kind of earned your way more than halfway to the 90, right? I mean, if the options here are only 89 or 90, if you hit a 0.5 or better, you're sort of halfway there. And so what we do for the sort of rules of rounding is that allows us to sort of round us up, and you sort of earned your way there. You're sort of more than halfway there. So this is going to become 475. All those digits stay exactly as they are, and the 8 is going to round this 2 up to a 3. So our rounded version ends up looking like that. Let's just kind of work our way up through the digits. Let's round to 3 decimal places. Let's round to the 1,000th. We'll just kind of take this and we'll just work our way up from right to left. So again, 536.47528. So I'm trying to round this to 3 places, so I'm looking between the sort of 5 and the 2. I'd like to end it after the 5, and I'm going to look back from the 5 to the 2. Now in this case, right, If I've got a 4 or lower, what's going to happen is I'm going to round down. So 5 or higher, meaning sort of halfway there or further along, what happens is you will round up, right? You sort of earned your way to the next value. If you're at a 4 or lower, you just didn't make it, right? You sort of didn't get to the halfway point, in which case you kind of slide back down to where you were. That doesn't mean, right, round down. That doesn't mean that you drop a digit, right? I mean, sort of all the digits that are here you've earned, so 536 points, so this is 4, 7, and then the 5 is kind of the digit that sort of we're questioning. So we've earned the 5. We're not going to drop from 5 to 4, so we're either at 5 or we're going to round up to 6, because we're at least 5, right? 5 and change. In this case, 5 and 2. So the 2 is just not enough to round us up from a 5 to a 6. It wouldn't really make sense. You can visualize this on a number line, sort of a zoomed in number line if you want. Is sort of a nice way to get a little bit of a visual going. So 5.36.475. So if you're rounding down, if you're not at, right, kind of 5 or higher, you just kind of erase the last digits. In some sense, they round down to zeros. And you just keep the other one the same. Let's do these last couple decimal places a little bit faster. So let's round to 2 places. So that's going to be hundredths. So 536.47528. And you'll notice what happened in the last one, right? You know, it's 28, but I never looked back at the 8, right? I'm only ever looking 1 digit past. So in this case, you know, round to 2 decimal places. So now I'm sort of stuck between the 7 and the 5. I'm looking back at the 5. Our 5 is, of course, 5 or higher. Check. So that's going to be a round up. So what's going to happen here, right, is we've sort of hit the halfway point, and just hitting halfway is enough. That's enough credit for us to round up. So this is going to be 0.48, right? So rounds from 7 to 8. The 2 and the 8 here are not having any impact. We're only looking 1 digit past all these other numbers that are sort of coming afterwards, after the fact. They don't really have a say. Honestly, you're only looking 1 digit past, right? You know, in some sense, if we look at the last one, you know, 2 is obviously small, but 8 is kind of big. You know, does the 8, you know, round this to a 3, and then this would kind of round up? And the answer is no. I mean, in some sense, 3 wouldn't round up anyway, but the idea is it's not like a domino effect of rounding. You're only looking 1 back. It's not like a sequence of rounding. You're only doing it once. Round 2. So 1 decimal place. Round this to the tenths. So 536.47528. Again. So between the 4 and the 7, looking back at the 7th, that's going to be 5 or higher. Check. That's going to round us up. And so that's going to round from a 0.4 to a 0.5. So 536.5. Check. Last but not least, what should we do? I guess we'll just round this to what we would sort of call the nearest whole number. Round to the whole number. So what that means is you're rounding away any of the decimal places. So 536.47528. So we're rounding kind of right at the decimal. We're trying to sort of round this, right? So we just have a whole value. We're dropping the decimals off. So our decimal values here, are we sort of at or above 0.5, or are we not? Are we, you know, in this case, we're sort of at 0.4 and change. 0.4 is not going to do it. This one's going to round down, right? This is 4 or lower. And so rounding down, again, what that's going to mean for us is we're just going to be left with 536. You wouldn't write 0.0. The idea is you sort of end it at that digit. The whole purpose here is to sort of drop off the digits that are coming afterwards. obviously in some sense 536 is equivalent to 536.0, but again, right, when you round, the idea is to write fewer digits, so you're only writing your digits to that place before the decimal. So 536 is where we would end it, and that's the basics.